focus only on row number row number 2. So 3 minus 3 0, 10 minus 12 minus 2, as you can see here, and 8 minus 6 2. Okay, now we are here. Next I want to make this minus 2 0. Okay, definitely I will keep row number 1, row number 2 as they are without change, and I will say, okay, let me multiply the first row by 2. This will be 2, this will be 8, this will be 4, and let add 2 minus 2 0, 8 minus 7 1, 4 plus 5 9. You see, it becomes 0. Now next I will use the determinant cofactor expansion directly 1 by the minor. This is the minor, it gives me the determinant. You see, when I use row reduction, the properties discussed for matrices, I can use them. Okay, now I need a joint. Okay, some new property to define here. If I have matrix m by n, which is a square matrix, then a joint of A is defined to be cofactor transpose of cofactor. Let me show you. This is the matrix. I will find cofactor for the first item, the second item, the third item, the fourth, the fifth, the sixth, the seventh, 8, 9, all of them. I don't need to explain it because we already know how to find cofactor for each one of them. It's the same formula, we apply it. Then I will construct a new matrix, I call it Cij, which have cofactor, the first cofactor, this one, equivalent to 2, the second cofactor equivalent to 1, and so on. So this is cofactor for each one element. Then I will do the transpose. We know how to do the transpose. This row will become the first column, this row will become the second column, this row will become the third column. Now what I did, I got a new matrix, I call it a joint matrix. I will need it later on. Now let's come to the inverse of matrices. Now if I have two matrices A and B, both, when I multiply them, I got identity. You remember identity? Identity as example 1 0 0, sorry, 1 1 0, or 3 1 1 1, everywhere 0. Okay, you remember this identity, we call it. It's like in scalar 1, the matrix which have diagonal with ones, otherwise 0. Now when I multiply them, I got identity. This means that if I take this to the other side, it will be B inverse. This means that one of them is inverse of the other. How can we do this? How can we find the inverse of a matrix? Now the idea is in this way. Have a look. We have different methods to find it. Okay, but let me make it clear. If I have two matrices B and another matrix A, and I multiply them, and I got identity AB or BA, I got identity, then this means one of them is the inverse of the other. Now how can we do inverse? The first method is easy. It's used only for 2 by 2 matrix. What it say? It say A inverse of matrix A here equal 1 over determinant, so we should have determinant not equal to 0, and the first two elements A and D will be exchanged their position, and B and C, we keep them in the same position, but we give them negative sign, change their sign. Example, you see here this matrix. Now I multiply 5 by 4 minus 3 by 6 is give me 2, which is the determinant. Now I come to 5 and 4, I exchange their position. 3 and 6, keep them in the position but change their sign. So since they are positive, I give negative. Now 1 over 2 can be multiplied by the items inside the matrix. This is the inverse. It's simple and it's used for 2 by 2 matrix. Another method is use the adjoint, also 1 over the determinant, but adjoint of the matrix. So I need to find the adjoint and divide it by the determinant. Example, this matrix, I already in the previous examples, okay, I already found the determinant. The determinant is 60, and find the adjoint. As I mentioned before, we find the cofactor matrix and then we do the transpose, we got the adjoint. Now next is substitute 1 over 60 by the adjoint. Now next I will use what we call elementary row operation. what elementary row operation? Elementary row operation is I have matrix A side to side with identity matrix. If I do the row reduction I just discussed to change things to be identity to the left and the new matrix to the right, then I have the inverse. B is the inverse of A. Let's explain this through this example. He gave me this matrix and he told me to find the inverse using elementary row operation. What I will do, I will bring the matrix. This is the matrix, and I will put the other side. I make a line here between them. I will put here the identity matrix, as you can see, the same dimension, 3 by 3. Now next I use row reduction, the property, okay, to make the matrix here is identity. It means diagonal ones and all elements are zeros. So let me start with from 3. This 3 need to be 0. So what I will do, I will keep row 1 and 2 as they are, and to make this 3 0 I need to multiply here by minus 3 by 4 minus 12 minus 3 by minus 1 3. Then I add, you see here R2 equal R2 minus 3 times R1. This is what I'm doing. So 3 minus 3 0, as you can see here. 5 minus 12 minus 7. 2 plus 3 is 5. Okay, now I'm here. Next I will zero next item, which is 2. So I keep the first row, second row without change, and then I will say, okay, the new row number 3 will be the old row minus 2R1. It means minus 2 by 1 minus 2 minus 2 by 4 minus 8 minus 2 by minus 1 2. Now and then add 2 minus 2 0, 2 minus 8 minus 6, 3 plus 2 5. You see I go 0. Okay, by the way, I'm not only multiplying here also I didn't focus on this, but as example here in the beginning when I multiply by minus 3, this is also minus 3, this is 0 0, and I add them because the same row, this is the same row. You see it's changed. 0 minus 3 minus 3, 1 minus 0 1, 0 minus 0 0, and so on. Here you see things gonna change to the right hand side. Now next I want to make this minus 7 1. So what I should do, row number 2 need to be divided by minus 7. So 0 on minus 7 minus 7, minus 7 over minus 7 1, minus 5 of minus 7, 3 of minus 7, and so on. Next I will make this minus 6 to be 0. Okay, then R3 will be R3 plus 6 times R2. So this R2 will be multiplied by 6 and then added to the row number 3. You see here I got it 0, and this one need to be 1, this one need to be 0, this need to be 0, and you see here I'm going in this direction. You see I change this, let me say this one into 0, this one it's also, as you can see here. Next I will change R3. I want to change this one to be 1. It's 5 over 7. I need to multiply all this element by 7 over 5. So I got it 1. And the same thing, I change this to 0, as you can see here. And finally I change this this one into 0. You see here what I got? I got identity matrix. Then this means that the other right hand side matrix represent inverse of the original matrix A. I put it in this way. All previous discussion I advise you to solve it. Now let me go to solve set of linear equations using inverse method. Now have a look here. You are given usually set of equations, as you can see here. Okay. Now first of all I need to convert this set of equations into matrix form. So what I will do, B to the other right hand side, it will be put in a matrix. Here it is A times X. So A matrix and X is another matrix, as you can see here. So A1 1, A1 2 into the end, A2 1, A2 2 into the end, and so on. And X will be X1 2 3 4 and so on. By the way, I can return back by multiplying row by column equal this one, and so on, one by one. What I need to find? A inverse, right? I did inverse as we learned before. I got A inverse is this. Now X is A inverse times B. This is A inverse and this is B. I multiply them. We know how to multiply. We got a new matrix X where this is X1, this is X2, this is X3. The idea is very simple and straight and direct forward, but the calculation need time and need practice. So I advise you to practice. Now I gave you here directly based on the previous examples, but you need to do it on paper, on piece of paper by yourself. Now the other technique to to solve set of linear equations is to use what we call it Gaussian elimination. Also, we are given set of equations. We put them now as A and B only. This is matrix A and this is matrix B. Okay, but we put them in a matrix and side to side. This one, make it 1. So I need to divide by 7 minus 7 the whole row. So you see here I got it 1. Next I want this minus 6 to be 0. I will multiply this row by 6 and add. I got a 0. Next I want to make this one 1. So I multiply by 7, divide by 5. So we got 1. Now when we reach here, what we will say, okay, now if I multiply x1 here, x2 here, x3 here, it should equal to 3. So since they are 0, then x3 is 3 directly. Now if I multiply this one by x1, x2, x3, it's supposed to be minus 7, as you can see here. Or x3 already got it here, so directly we can find x2. The same thing here, x1 by x2 by x3 equals 6. We have x2, 3. Let me find x1. I got them. This is called, as I mentioned, Gaussian elimination. These are extra problems. I advise you to try to solve them, and the practice is important here. Also, these are some exercises. I advise you to do them. Have a nice day, and I will see you in the next session.